In the given question, we find that a weightless rod AB of length 1 meter is supported horizontally at the points A and B, and the weight of the rod is 500 newtons. And the weight is placed at a point C. C is somewhere on the rod. It is not at the middle. And the force at A is limited to 300 newtons. Let's call this as RA. So RA is limited to only 300 newtons. Find the distance of C from A when the support at A is about to fail. So the weight will be passing through point C, and there is one more support at point B. So here you can see a given problem is identical to a scenario where two persons are carrying a table, and on that table a weight of 500 newtons is being placed, and the person at point A is having the capacity to withstand only or lift only 300 newtons or 30 kgs, okay, with the bare hands. And if that is the case, the location or the person at the point B should be lifting 200 newton force. So this is what we can understand or what we can interpret from here. So here the limited case is 300 newtons, and you can place the weight in such a way that the load at point A can be below 300 newtons also. That is, this 500 newton force should be moved closer towards the point B. If it is moved closer towards point B, obviously the weight or the reaction at location A will be less. Okay, so here it is asking that when the support at A is about to fail, then what is the location of the weight? Let's say the distance x from point A up till the weight W, and the span of the rod AB is 1 meters, and this distance of W from point B would be 1 minus x, because the length of rod AB is 1 meters. Now if we take the moments about the point B, and this rod will be in equilibrium, okay, because we find the direction of W opposite to RA and RB, which means summation of upward forces is equal to downward force, then we can claim that body is in equilibrium. So moment about B is equal to RA into 1 is equal to W into 1 minus X. RA is 300 into 1 and W is 500 into 1 minus X. So here this is 0.6 equal to 1 minus X, and X will be equal to 1 minus 0.6, that is equal to 0.4 meters. So from point A, the load has to be placed at a distance of 0.4 meters. Only then the failure of A is about to commence, or the failure of the support at A is impending. If the value of X is decreased to 0.39, then the support A is definitely going to collapse.